Okay, now that we know a little bit more about this concept of encapsulation, let's explore a little bit deeper. Let's explore why encapsulation is needed, and perhaps more importantly, how is it useful in computer science? So we can think of encapsulation as a container that puts things together. Encapsulation can group certain pieces of information together. For example, in computer science, we call these containers objects that encapsulate related information. So we can think about encapsulation as keeping things together, but that's not the only thing that encapsulation offers. Encapsulation has another idea behind it. This idea is called black boxing. Simply put, black boxing means that we give the standard input to the object and the expected output. And we don't really want to know about the inner workings of the object as long as it works. For example, your television. Your television has a lot of inputs that come out of the controller when you press buttons. You send signals to the TV, and then it outputs something to the screen. The way the television goes about receiving signals and doing all the rest is really not your concern. All you really care about is pushing a button and for it to perform the expected action. In fact, you don't really care if all the inner workings of your TV were changed, as long as you can push a button and the desired output comes out. You really don't care about anything from the technical side at all. In a way, we do the same thing in object-oriented programming, like in the television example. In some applications, it is best that the users don't know about or care about the inner workings of the process. Often, programmers must design objects that require hidden data. Well, you might say, why do we want to hide stuff from ourselves? We're the programmers. We should be able to access everything about the objects we design. Well, there is a very, very good reason why we don't want just any code in our programs, or anyone else's programs for that matter, to access all parts of our objects, especially the data parts. To better understand the reasons for hiding data, let's take a use case scenario from banking. Imagine you are creating a banking application and you need data from individual bank accounts. Now, all these bank account records or objects have a balance. Do you really want any program, any code to just modify the account balance? I don't think so. It makes sense that every time a user withdraws money or deposits money, it affects, as it should, the balance of an account. It is also very likely that for security reasons, just to name one reason, we would want to keep a record or a log of all actions that change the balance of an account. That is, we should record all of the withdrawals and deposits. In this case, we use that familiar concept, black boxing. What we do is we prevent other programs from directly affecting the account balance. In that way, this black boxing will prevent any application from bypassing the logging of activity on an account balance. Because if programs could directly change that value, we could not maintain an accurate log of all transactions that affect the balance. So what we do is we hide the balance. It can't be changed directly. All changes to the balance must go through the withdrawal or the deposit method. When all programs are forced to go through either the withdrawal or deposit method, it means that all changes in the balance will automatically insert a record into our log. So that is why black boxing is important to us as programmers. We actually know how our objects must work. So what we do is we make sure the data is accessed correctly so that no one can just randomly change certain aspects of our data without going through certain processes before that change can be made to that object. Computer scientists call this concept of restricting access data hiding.